Now we've seen that electrons have got a property called spin that makes them act like little bar magnets. There are a couple of important technological applications of that I'd like to talk about. The first is spintronics. And it's got a lot of applications in computing and some in medicine too. Let's look at computing. You probably already know that computers store information as a series of ones and zeros. So you can take a character on a printed page, you can take a pixel in a picture, take any sort of information and encode it so that it can be stored or read as a series of ones and zeros. Well, electrons can be spin up or spin down. If you had a way to set the spins of electrons, and if you had a way to read the spins of electrons, you could use electron spin as a way to store information. Now, technologically, it's very difficult to do, but a lot of progress has been made. Not with using individual electron spins, but groups of electron spins. So here you could have a sample that is mostly spinning in that direction, and here another sample that is mostly spinning in that direction, and use that for storage. So this will give us next generation computing devices that have superior power consumption. They'll consume much less power, and they'll also be much, much smaller than the devices that we have today. And you could be seeing spintronic devices, spintronic things in consumer electronics within 5 years. They're that far along with this. Another really great application of this is in medicine. If you have the ability to read spins, you have the ability to sense changes in spin that occur with chemical reactions. And these are accompanied by little magnetic signals. And there are a lot of reactions that occur in your body that produce little magnetic signals that could be read with some kind of spintronic sensor that would sense changes in spins. For example, every time your heart beats, there is a little magnetic pulse associated with that. Every time your white blood cells are fighting bacteria, there are electrons that flow in chemical reactions there that produce a tiny, tiny magnetic pulse which can be sensed. So a spintronics device could be used to detect disease conditions or abnormalities as magnetic signals. It's that sensitive, and it could even do it from outside the body. So that's kind of an emerging technology that's based on electron spins. There is an older technology that has saved millions of lives. And you probably heard of this too. Magnetic resonance imaging, MRI. Every hospital of any size has got an MRI machine, or has one nearby, one accessible, because this has become just essential for diagnosing different kinds of cancers. All right, how does it work? Well, it doesn't use electron spins. It uses proton spins. So protons, just like electrons, are charged particles that can spin, and they can have associated with them, because of that spin, a magnetic field. So they act like little bar magnets, essentially. And if you put your body between a very strong, the poles of a very strong magnet, the protons in your body will mostly line up with that magnetic field. There'll be a couple that are against it, but most of them will line up with the very strong magnetic field. Now, why do you have protons in your body? Well, they're hydrogen nuclei, right? So you have a lot of water in your body. That's H2O. There are all kinds of protons there in just the water in your body. But also fat and protein, all of those things have got protons in them. Now, this would be the sort of resting state for the proton spins in your body. If you got a radio signal and sent it in, and it was just the right wavelength or frequency, it could put those spins from the ground state, all aligned like this, into an excited state by flipping them. Now, let me oversimplify just a tiny bit and say here is the state where they're all aligned. And now, when you send this radio signal in, it'll put them in an excited state where they're not aligned. And actually, it will set them spinning perpendicular to the field, and there are some details about how it gets out of that state. So it's not just two states here, really, that we're talking about. But this is a good way to think about it. This is the low energy state. You send the radio pulse in and get them all up into the upper state. Now, stop the radio. Stop sending in the radio signal, and then they will collapse down. They will relax back down to the ground state. And there'll be a change in energy. And you know what that change in energy will be. It will be the energy of the photon that you see coming out. So photons will be emitted when these things relax back to their aligned state from their misaligned state. And you could detect the frequency and the wavelength of the radiation that was coming back out that way. So what? You could measure the energy level spacing. This is kind of what you did in your line spectrum experiment, right? How does this have any kind of medical bearing? I mean, what's its importance? Well, it turns out that the time it takes for them to collapse down to the lower state, as well as the energy level spacing itself, is very sensitive to environment. Now, what do I mean? It depends on the environment. Well, when you've got a proton spin, it's not just isolated. It's around a lot of other spins, too. And say it's around a bunch of spins that are fighting it. Well, that'll make it easier to flip over. And it'll be less energy for it to flip it back in alignment. That will change the energy level spacing and also how fast it flips from one place to another. So these neighboring spins will create a magnetic field around this that will influence the energy level spacing and the time for the transition. So what? Well, in healthy tissue, there's a different water content, different fat content, different protein content than in a tumor. There are a lot of changes that occur in a tumor. So the environment in a tumor is different than the environment in a healthy tissue. And you will get a different signal, and you'll see the signal, you'll see a different time for the signal to evolve than you will in healthy tissue. So there'll be a change in signal between healthy tissue and diseased tissue. So what they'll do is put you on a pallet and put you in a big tube. And the tube will basically have an extremely powerful magnet going through you. And then there are radio frequency generators that will do the spin flipping thing, and they are located very cleverly all around the tube so that they can send the radio in to a specific spot and get a signal from a specific spot and make a map, a detailed map then of the signal that comes back, which can be related, changes in that can be related to whether it's healthy tissue or cancerous tissue. Say you've got a tumor and it's in something very sensitive, like say your brain. So you've got maybe a tumor that's got a lot of little fine tendrils that stick into the rest of the tissue. Now in the olden days, they'd have to open you up and poke around in there and see the shape of the tumor and sort of play it by ear once they saw what it looked like. But now, since they can get a detailed map in 3 dimensions of the tumor before they even open you up, your ability to survive surgery like that is much, much higher than it was other times. So not only is this an important medical technology that has saved a lot of people's lives, but making these machines is $1 billion a year industry. So there is a whole chunk of the economy that didn't exist before this technology existed. So medical, economic benefits from this.